This lesson is on maximum and minimum word problems. This can also be called optimization because you are finding an optimal answer. First situation is a very classic situation. We have 100 feet of fence to make a rectangular pen, and one side is a barn and it does not need fence on that side. What is the maximum area that we can enclose, and what are the dimensions of that pen? So I always start by drawing myself a picture. Okay, I'm going to pretend this is the wall of a barn, and here's my pig pen or whatever coming off the side of it. So I don't need fence on this big long side that's the barn. I just need fence on these three sides. And I always approach this with the same technique. These two sides that are that I make vertical, that are across from each other or parallel, I'm going to call that X. And that X represents how much fence I use there. And they obviously have to be the same because it is a rectangular shape and the opposite sides are the same length. So I have X amount here and X amount here. And so if you think about that, those like numbers, if we have 100 feet of fence, how much would be left on this third side? Well, if I used 10 here and 10 here, I would have 80 left, because that would be 100 minus 10 minus 10. Well, since these are X, I can just say 100 minus 2 X's, because I need it to be generic until I figure out what that X actually is. Okay, well, what are we trying to maximize? We are trying to maximize our area, and if you think about how you get the area of a rectangle, it's length times width. And the two sides of our rectangle are X and 100 minus 2X. So that would be how I would find that area. And since we are doing quadratics, I'm going to go ahead and distribute that just so it looks like a little more of what we're used to. So I'm going to have 100x minus 2x squared. I can rearrange that and make it negative 2x squared plus 100x. So you know it's a parabola that's facing down because of that negative. Before we do anything else, we're going to talk about what that means, what that point's going to mean. So since we're finding the maximum, we're going to be finding the maximum on the graph. And that point, if you look at this equation, x is x, but the y is an a. So when you find the maximum point on your calculator, or however you find it, the x value is the side of the fence, or the side of the rectangular enclosure, and the y value is the area at that amount. Okay, so all we really need to do is find the maximum. So I would like for you to use your calculator to find the maximum. I want you to type this negative 2x squared plus 100x into y1 and graph it. Now you will probably have to change your window because you need to see the top of that hill in your window. So if you need to work on that, hit pause and work on finding that window. Then you want to calculate the maximum, and so you want to go second trace, which is your calculate menu, and you want to go down to the one that says max or maximum and hit enter. It will then say left bound and right bound, and the left bound will be the first question. So you want to get on the left side of that high point, somewhere like here, and hit enter. Then when it says right bound, you want to get on the right side of that point, so maybe over here, and hit enter. You should get two arrows that pop up above it, and that maximum point should fall between those two arrows. When it says guess, you can try to get your cursor on top of the maximum point, or you can just hit enter. It'll usually figure it out. And in this case, you should be getting a point of 25, 12, 50. So what does that mean? That means our answer to A, the maximum area that we can enclose, is that 1250 square feet. And I know it's feet because it was 100 feet of fence. The B, what are the dimensions of the pen? That would be the length and the width. So you have to come and think about what happens if I plug those in. Well, X is obviously 25, And if I plug in 25 for this x, 100 minus 2 times 25 would be 100 minus 50. So that means this side is 50. So our dimensions for the answer to part B are 25 feet by 50 feet. And you could write out FT if you wanted to. I'm just using that little mark. Whatever works for you, just to make sure you have units. Okay, for example 2, we're going to use a similar situation, but we're going to have 220 feet of fence, and we are going to have to use the fence on all 4 sides. So we're not going to have a barn or anything on that one side where we don't need a fence. So when we draw our picture this time, we need to draw a full rectangle and consider putting the fence on all 4 sides. I'm still going to start by labeling these 2 vertical sides with X because that's just my habit and the way it works. You could do the other 2 sides. And then you have to think about what's left. Well, before, when we used our fence, we would take that total amount, 220, minus these 2 X's, and that's how much we have left. However, this time we have to divide it between 2 different sides. So it's thinking about it like saying I have this much left, but I have to divide that by 2 because I need some on 2 different sides. Well, if you divide this by 2, nice numbers here, we get 110 minus X. So that will represent one side, and it will also represent this opposite side. So there's 110 minus X left on each side. And then you go about the process the same way that we did before. So area is length times width, and our sides are X and 110 minus X. And then I want to distribute. So I have 110 X minus X squared. I will rearrange that just to make it look better and remind me that that is an upside down parabola. And again, when I think about that maximum, my X is representing the distance on the sides of the pen, and the Y is representing area. So I'm going to use my calculator to calculate that maximum value and find that in the window. And that gives me 55 and 30, 25. And so I would answer with maximum area of 3025 square feet, and then my dimensions, when I plug in the 55, I have 55 on these opposite sides, and then 110 minus 55 is also 55. So this actually ends up to be a square, giving us the maximum area. So our dimensions are 55 feet by 55 feet. Before I go on, I want to talk about one more way that you could find this vertex. Let's say that you can't find it in your window, or you're struggling, or maybe you're on the calculator inactive part of a test at some point. You can use negative b over 2a to find your x, and the b and the a are like we have in the quadratic formula. So in this case, b is 110 and a is a negative 1. So our x is negative 110 over 2 times negative 1, which gets you that 55. So it's just an algebraic way to get that 55. And then you could get the area from plugging that back into the equation that we found here. So negative 55 squared plus 110 times 55, and that will give you that 3025 that we found using our calculator. So this is an algebraic way to find that, and you don't have to use it. The calculator is nice and convenient, but sometimes hunting for that window where you can see the maximum is a pain, and this might be quicker. And like I said, you may be on a test at some point that you're not allowed to use a calculator. So this x equals negative b over 2a is a very helpful piece of information. Okay, example 3 is a little different. We're going to be talking kind of going into science here. The height of the ball is thrown in the air, or excuse me, the height of a ball that's thrown in the air is given by this equation. We have 3 questions. What is the maximum height? When does it reach that height? And when does it hit the ground? So obviously this again is going to be an upside down parabola because it is a negative t squared type thing. When you graph it in your calculator, we're not sure where it will be at the moment till you actually do that, but let's think about what these things tell us. We are looking for the maximum height and when it reaches that height. And so the maximum obviously is going to be at the top. And what does that point at the top represent? And so our x's are now t's when we look at the equation. So where we normally have an x, we are now having a t. And then our y is this output h of t, which is the height. So I'm going to put h of t, but that's height. So time and height. And if you want to write that out in words, that might even help you more when you're trying to interpret your answer. So time is our x value. Height is our y value. We'll know what we get when we solve it. The other thing they ask about is when it hits the ground. And the ground on our graph is the same as the x-axis because that's when the height is 0. So we're also going to be finding this point over here, which is a 0. And at that point, the x value is still a time, but the height is 0. Or it should be 0 because that's when we're hitting the ground. So we're going to use our calculator again, and we're going to get those 2 points. And so when I actually graph it in my calculator, it looks something like this. And so I'm going to second calculate that maximum and use that left bound and the right bound, and I get the point 0.255. And then you have to calculate the 0, so second calculate the 0. You have to be on the left side and the right side, so that happens to be above and below this point. And I'm going to calculate that point. So 0.809 and 0 as we expected that it would be. Okay, so now let's interpret our answers. For part A, what is the maximum height? And that is the y value at the max, which would be 5 feet. When does it reach that height? That's the time at that point, so that's that 0.25. So 0.25, we'll say seconds. And then when does it hit the ground would be this 0.809 seconds. So once you understand what those points are representing, getting the answers is really easy, and your calculator does most of the work. Once again, I want to point out that x equals negative b over 2a will get you the same things. So if you wanted to get that maximum value, now this gets the maximum, not the 0, by the way. That maximum value, your a is the negative 16 and your b is the 8. So negative 8 over 2 times negative 16 will give you 1/4, which is 0.25. And then if you plug that back in, h of 1/4 or 0.25, you get negative 16 times that squared plus 8 times 1/4 plus 4. That will give you 5. And so you get the same values that you get at that maximum point. This is just how you do it algebraically if needed. Okay, the last one. What is the maximum product of two numbers whose sum is 40? When you first read this, you're probably like, we do not have enough information to do this. So we actually do. We have product of two numbers, and we have sum of 40. This actually gives us two different equations. So product of two numbers means that if I multiply two numbers, I'm getting some answer. And we want to know what that maximum product is. So I'm just going to say the product of those two numbers. I'm going to have to call those two numbers some kind of variable. You can use n and m or p and q or whatever. I'm going to use x and y because we're pretty used to those. So we have two numbers that we have a product. We're multiplying, and that product is whatever that number is. We don't know. We know, however, that their sum is 40. So if I add them, x plus y, I get 40. So I've just made two equations off of that sentence that seemed kind of sparse. Okay, so what do we do now? We are trying to maximize the product, and just like in the other problems we were trying to maximize the area, so this is the one that we're really going to work with. The problem is you actually have three variables here. So the reason they gave you this x plus y equals 40 is to get this down to one variable, and you're going to do that by using substitution. So I'm going to subtract x and have y equal 40 minus x. I'm going to take that and I'm going to substitute that in for the y in this product. So my product will be x times 40 minus x. And then this looks really similar to the other problems we've been working with in example 1 and 2. So I can distribute that out and get 40x minus x squared. I can rearrange that if I need to. You don't have to. It's just a personal preference. But it reminds me that it's an upside down parabola. So let's think about what that means. Our point at the top of that. The x values here are still called x, and they represent one of the numbers. So when we find that maximum value, we're going to find one of those numbers that we're trying to find. And then the y value, if you look at this equation where we normally have a y, now we have a p, and that's standing for their product. And so that y value is now p. So this is one of the numbers and the product. So hopefully that can help us answer our question. Again, you can use the graph on your calculator to find that maximum, but I'm going to go ahead and use that negative b over 2a this time. So x equals negative b, which in this case is 40, over 2a, and a is negative 1, and I get out a 20. That means that one of my numbers is 20. And so I can find the other number by plugging into this x plus y equals 40. So if 20 plus y equals 40, y has to be 20. So x is 20, y is 20. Those are our two numbers. They could have asked that, but they wanted to know the maximum product. So they actually wanted to know what p was. So if I plug in x and I plug in y and find their product, I get 400. And so that is my answer. Our maximum product is 400. Our two numbers are 20 and 20. Now, if you calculated this in your calculator, if you did the maximum, obviously that point that you would have found at the top would have been the x value of 20, and then the p, the product of 400. So either way, you get the same answer. And that's just how you work that one. So that concludes this lesson.